Hi everyone. Today we're going to be talking about the converse of the Pythagorean theorem. So, recap from what we've already learned. We know that if it's a right triangle, we can use a squared plus b squared equals c squared in order to find any missing length of that triangle. Now we're going to be talking about the converse. Now converse is kind of like a backwards technique. If we make a statement that said that um, it's raining outside, therefore the ground is wet. The converse of that would be kind of taking the two parts and switching them around. So instead, we would say since it's the ground's wet, it's raining outside. So we're kind of reversing it. So the converse of the Pythagorean theorem is if a squared plus b squared equals c squared, then the triangle must be a triangle. So that's really important to know. If a squared plus b squared, so if the two legs squared equals the hypotenuse squared, it has to be a right triangle. There's no other way around it. So taking a look at our example here, you might be asked, is this a right triangle? So in order to identify it, we're going to do what we did before, which is identify A, B, and C. And remember, C is always the longest side. So I will say that 15 is my A, 36 is my B, and 39 is my C. Because 39 is the largest side, that's why it has to be C. So my step 2 is to plug into the numbers into a squared plus b squared equals c squared. And after squaring, if a and b equal c, then yes, it is a right triangle. So I have my 15 and I square it, and I'm adding that to my 36 squared. And we're going to see if that equals 39 squared. Well, 15 squared is going to be 225. 36 squared is going to be 1,296. 39 squared is 1,521. So when I add my A and my B after they're squared together, I have in this example 1,521. And yes, that does equal 1,521. So I know for sure that the triangle that I have right here is a right triangle. Great. Let's see how else the Pythagorean theorem can help. So it's not just for right triangles that the converse of the Pythagorean theorem can help us identify. We can also use the Pythagorean theorem in order to identify acute and right triangles. So if a squared plus b squared is larger than c squared, then the triangle must be acute. And remember, an acute triangle is a triangle that has all sides small or all angles smaller than 90 degrees. So a squared plus b squared is less or is greater than c squared, then that means that it is acute. So let's take a look at this example. We're going to use the same steps that we used above. We're going to identify A, B, and C, with C being the longest side. So I have A is 17, B is 19, and C is 22. So again, I'm going to apply it into the equation where I am going to square both A, B, and C, but add A and B together. So I have 17 squared plus 19 squared, and we're going to see that relationship with 22 squared. 17 squared is 289, and I'm adding that to 19 squared, which is 361. We're going to look at that relationship with 22 squared, which is 484. If we add 289 plus 361, you get 650, which is greater than 484. So because a squared plus b squared, the two legs squared added together, is greater than the hypotenuse squared, then we know that this is an acute triangle. Now, as you probably can figure out, the last one we're going to be looking at is an obtuse triangle. An obtuse triangle is a triangle that has one large side or angle of their triangle that is larger than 90 degrees. So again, we're going to use the converse. So our converse is that if a squared plus b squared is less than c squared, then the triangle is obtuse. So a squared plus b squared is less than c squared, then it is going to be obtuse. And again, we're going to follow those same steps as we did before. We're going to label a, b, and c, with c being the largest side. So I have 14 as my a, 18 as my b, and 23 as my c. We're then going to plug it back into the equation as usual, and we're going to square them along with adding a and b after that. So we have 14 squared plus 18 squared, and that is in some relationship to 23 squared. 14 squared is 196. 18 squared is going to be 324, and 23 squared is 529. If we add our two a and b up together after squaring them, we're going to have 520. And in relationship to our c squared, which is 529, that is less. So that means that this triangle here is obtuse. What's really important to know is that the legs A and B can be switched. So if you had 18 for A and 14 for B, that is okay, but the C has to be the longest side. And another important thing to do is make sure you do the math. Just by looking at the triangle, you might be able to tell if it's acute, obtuse, or right. However, don't rely on your eye because sometimes it is not drawn to scale. So it might look one way, but it actually would be another way. So make sure you do the math and make sure that you are applying the converse of the Pythagorean theorem.